Let me start with a simple question. What do you mean when you say something happened in the past? You mean it happened before now, right? And something will happen in the future if it happens after now. Seems obvious. The past is done, finished, over with. The future hasn't happened yet. And right now, this moment, this is the only thing that's real. That's what we all think. That's what I thought for a long time. But here's the problem. When you really look at what physics tells us, when you take Einstein's relativity seriously, this whole picture falls apart. And I mean completely falls apart, because it turns out that now is not something that everybody agrees on. And if we can't even agree on what now means, then how can we say what's past and what's future? Let me give you an example. Imagine you're standing on a train platform, and I'm on a train that's moving past you at a good clip. Now there's a star out there, Alpha Centauri, about 4 light years away. You look at it and you say, I wonder what's happening on Alpha Centauri right now. That seems like a perfectly reasonable question. What's happening there now? But here's the thing. There is no now at Alpha Centauri that we can both agree on. What you call now at Alpha Centauri and what I call now at Alpha Centauri as I'm moving on this train are different moments. They could be hours apart or days apart depending on how fast I'm moving. We literally cannot agree on what is happening at Alpha Centauri at this moment. Now you might say, well, Feynman, that's just because we're confused about the signals, about the light travel time. No, no, no. This is not about signals. This is not about what we see. This is about what is. According to Einstein's theory, which has been tested to incredible precision, simultaneity itself depends on who's asking the question. Your now across the universe is different from my now across the universe if we're in relative motion. Think about what this means. Imagine there's something happening on Alpha Centauri right now in your frame of reference. Maybe there's an alien civilization there and somebody just decided to have coffee instead of tea. In your reference frame, that's happening now. But if I start moving relative to you, my now at Alpha Centauri might shift to yesterday or tomorrow. The alien's choice might be in my past or in my future, depending on which direction I'm moving and how fast. And here's the kicker. That alien's choice, whether they have coffee or tea, that event exists. It's real. It's part of the structure of space-time. It's just that whether we call it past, present, or future depends on our motion through space-time. So what does this tell us? It tells us that the universe isn't really a 3-dimensional space where things happen in time. The universe is a 4-dimensional structure, what we call space-time. And all the events, everything that has happened, everything that is happening, everything that will happen, they're all laid out in this 4-dimensional structure like beads on a necklace, except it's not a necklace. It's this complicated 4-dimensional thing. Let me try to make this clearer with a diagram, a space-time diagram. You've probably seen these. We put time going up and space going sideways. Now, your life is a line on this diagram. We call it your world line. It's every moment of your existence from your birth to your death, all laid out in space-time. My world line is next to it. The world line of Alpha Centauri is over there, and so on. Now, here's what's interesting. In this picture, your past is all the events that could have affected you. They're down there in your past light cone. The future is all the events you can affect. That's up there in your future light cone. But there's this whole other region, this huge region of space-time that's neither in your past nor in your future. It's what we call elsewhere. And here's where it gets really strange. Events in this elsewhere region, whether we call them past, present, or future, depends entirely on our reference frame, on our state of motion. What's simultaneous with you now in one reference frame is in the past in another reference frame, and in the future in yet another reference frame. So when we say the past is gone, what do we really mean? We mean that those events are in our past light cone. We mean they've already affected us, or they could have affected us. But the events themselves, they're still there in space-time. They haven't gone anywhere. They're part of the structure of the universe. Think about it this way. When you look at a photograph of yourself as a child, you don't think that child has vanished from the universe. You know that child was you at an earlier time. Well, in space-time, it's the same thing. Your childhood self is sitting there in space-time at an earlier position along your world line. It's as real as you are now. The only difference is your consciousness is experiencing this moment right here, not that one back there. This is what Einstein meant when he wrote to the family of his friend Michel Besso after Besso died. He said the distinction between past, present, and future is only a stubbornly persistent illusion. Now, he didn't mean that things don't happen in order. Cause and effect still work. if you're in my past light cone, you can affect me. If you're in my future light cone, I can affect you. That structure is absolute. Everyone agrees on it. What's not absolute is this notion of the present moment extending throughout the universe. There is no universal now. And if there's no universal now, then past and future are not absolute categories. They're relative to the observer. Let me give you another example that really brings this home. Imagine two events happening far apart in space. Let's say one happens on Earth and one happens on Mars. In one reference frame, they happen simultaneously. In another reference frame, the Earth event happens first. In a third reference frame, the Mars event happens first. And all three of these reference frames are equally valid. None of them is wrong. Now you might think, well, surely the two events really happened in some particular order, and we just can't tell what it is. But no, that's not what physics says. Physics says that if two events are space-like separated, meaning they're far enough apart in space that light can't travel from one to the other, then their temporal order is not absolute. It really does depend on the reference frame. And this is where we get to the heart of it. In the space-time picture, all events are equally real. Your birth is real. Your death is real. Everything that happens in between is real. And they're all sitting there in space-time in this four-dimensional structure. Now, you might say, but Feynman, I experience time flowing. I experience the present moment moving forward. Yes, you do. I do too. And that's very real. But that's something about your consciousness, about how your brain processes information. It's not something fundamental about the structure of space-time. Here's a way to think about it. Imagine space-time is like a movie that's already been filmed. The whole movie exists, but when you watch the movie, you experience it frame by frame. You experience the story unfolding. You don't experience all the frames at once. Our consciousness is like that. We experience space-time moment by moment along our world line, even though the whole four-dimensional structure exists all at once. And here's something else that's absolutely fascinating. In quantum mechanics, things get even weirder. I developed a way of thinking about quantum particles where they don't take a single path through space-time. Instead, they explore all possible paths. An electron going from point A to point B doesn't just take one path. It takes every possible path. And we have to add up the contributions from all these paths to figure out what the electron does. Now, some of these paths, the electron goes forward in time. Some of these paths, in a certain mathematical sense, the electron goes backward in time. And this isn't just mathematics. When we talk about antimatter, about positrons, one way to think about them is as electrons moving backward in time. My colleague John Wheeler once called me up and said, I know why all electrons have the same charge and the same mass, because they're all the same electron moving back and forth through time. Now, I didn't buy that particular idea, but the notion that particles can move backward in time in the right mathematical framework, that's part of how we understand quantum field theory. So in quantum mechanics, the distinction between past and future becomes even more blurred. Particles are exploring all possible histories, including ones that go backward in time, and we have to account for all of them to predict what we'll observe. Now, let me be clear about something. When I say the past hasn't gone, I don't mean you can change it. You can't. The structure of space-time is what it is. Your world line is laid out in space-time, and you're experiencing it in a particular direction, from past to future. You can't go back and change things. The causal structure is fixed. What's in your past light cone can affect you. What's in your future light cone, you can affect. That doesn't change. But the events in your past, they're still there in space-time. They haven't disappeared. They're part of the permanent structure of the universe. And events that you think of as in your future, they're also there in space-time. Your future self, if we could look at the whole four-dimensional structure, is sitting there just as real as your past self. Now, this raises all sorts of philosophical questions. If the future is already there in space-time, does that mean we don't have free will? Does that mean everything is predetermined? I don't know. That's getting beyond physics into philosophy, and I don't like to speculate too much about philosophy. But I can tell you what physics says. Physics says the laws of nature are deterministic at the classical level. If you know the state of the system now, you can predict what it will be in the future. And if the future can be predicted from the present, in what sense is it not already determined? Quantum mechanics throws a wrench into this with its fundamental randomness. But even there, the whole space-time structure exists, and we're just uncertain about which branch of the wave function we'll find ourselves on. Let me try to bring this all together. The reason we think the past is gone is because we experience time as flowing. We remember the past, we don't remember the future, and we experience this moment as special, as now, and all of that is real from the perspective of our consciousness. But when we look at the actual structure of space-time, when we look at what the laws of physics tell us about the universe, we find something very different. We find that all events, past, present, and future, are part of one four-dimensional structure. We find that simultaneity is relative, that there is no universal now. We find that your past and future are directions in space-time, much like north and south are directions in space. And the arrow of time, the fact that we remember the past and not the future, the fact that entropy increases, the fact that we age, all of that has to do with the initial conditions of the universe, with the fact that the universe started in a very low entropy state at the Big Bang, but it's not a fundamental asymmetry in the laws of physics themselves. Most of the basic laws work just as well backward in time as forward. So is the past really gone? From the perspective of space-time, no. The events of the past are sitting there in the four-dimensional structure of the universe just as surely as events happening now, just as surely as events in the future. They're at different positions in space-time, in the time direction, but they're all equally real. Your childhood, if we could look at all of space-time at once, is there. Your old age, if we could look at all of space-time, is there. Every moment of your life is a different slice along your world line through this four-dimensional structure. Now, I know this is hard to wrap your head around. It goes against everything our intuition tells us. Our brains evolved to think about time as flowing, to think about the present as special, to think about the past as gone and the future as not yet here. But physics tells us something different, and you might ask, why should I care? What difference does it make if the past is still there in some abstract space-time structure? Well, I think it matters because it changes how we think about the nature of reality. It tells us that the universe is bigger, stranger, and more beautiful than we imagined. It tells us that your entire life, everything you've ever done, every moment you've experienced, is part of the permanent structure of the cosmos. In a way, it's comforting. Nothing is really lost. Every moment that ever was, still is, in space-time. Your first day of school, your first love, your greatest achievements, they're all still there, painted into the fabric of the universe. But it's also humbling. It means we're not standing at some special moment in time. We're just traveling along our world line through this vast four-dimensional structure, experiencing it moment by moment. But the whole structure exists whether we're experiencing it or not. You know, when I think about this, when I really think about the implications of relativity, it fills me with wonder. The universe is not what we think it is. Time is not what we think it is. The past is not gone. The future is not non-existent. They're all there, all part of this magnificent four-dimensional tapestry that we call space-time. And we're part of it. Your world line, my world line, the world line of every particle in the universe, they're all threads in this tapestry. And when you understand that, when you really get it, you see the universe in a completely different way. So the next time someone tells you the past is gone, you can tell them, not really. It's still there in space-time. We've just moved past it along our world line. And the future, it's already there too, waiting for us to experience it as we travel forward through space-time. That's what Einstein's relativity teaches us. That's what the structure of space-time tells us. And it's one of the most profound insights we have about the nature of reality. The universe is a four-dimensional structure, and time is not what we thought it was. The past is not gone. It's all still there, and it always will be, woven into the eternal structure of space-time. Thank you.